Welcome back to the Learning Studio. You're watching our mathematics series, where we explore the foundations that power science, technology, and artificial intelligence. If you're joining us for the first time, make sure to follow us by clicking the link below. And don't forget, the full playlist is also added in the description, so you can catch up on every episode at your own pace. Today, we're stepping into a field that quietly powers every computer simulation, every engineering design, and every AI algorithm that needs to crunch massive amounts of data: numerical analysis. Here's a scenario for you. Imagine you're designing a spacecraft. The equations that describe its motion are incredibly complex, too complex to solve exactly with pen and paper. But the spacecraft has to launch on time, and you need answers. What do? You approximate. And that's exactly what numerical analysis does. It finds practical solutions when exact answers are impossible or impractical. In other words, it's the mathematics that makes computation possible, core concepts explained simply. Let's break down the key ideas. Approximation. Not all equations have neat solutions. Numerical methods give us close enough answers, accurate within a tiny error margin. For example, calculators and computers don't give exact values for square roots or trigonometric functions. They use numerical approximations. Error analysis. Every approximation comes with an error. Numerical analysis doesn't just give answers, it measures how far those answers are from the truth, so we can trust the results. This is critical in fields like finance, engineering, and AI, where even small errors can have big consequences. Solving equations computationally. Many real-world problems lead to equations that can't be solved with simple algebra or calculus. Numerical analysis provides iterative methods, step-by-step approaches that computers use to get closer and closer to the solution. Why it matters in AI and technology. Now you might be thinking, how does this connect to artificial intelligence? Well, every time you train a deep learning model, you're solving massive systems of equations with millions of parameters. Numerical algorithms make this possible. Optimization methods, error corrections, simulations of neural networks, they all rely on numerical analysis. Without it, modern AI wouldn't just slow down, it wouldn't even run. So numerical analysis is more than just number crunching. It's the hidden engine that turns mathematical theory into real-world solutions, making science, engineering, and AI practical. In our next episode, we'll dive deeper into the rigorous side of mathematics with real analysis. This is where we study the very foundations of calculus: limits, convergence, and continuity, the tools that bring precision and proof to everything we've learned so far. Make sure to follow us by clicking the link below, and don't forget to check out the playlist in the description. We're building this journey step by step, and the next chapter will take us closer to the heart of mathematical rigor.